bang noise? Okay. So that's what's going to pull you down after you make your pull. Like you're going to run all the way up, and as soon as you lift, I'm going to grab the brake and pull back down to 0 miles per hour. When you're in the car, I tell you to start moving the wheels or whatever. You know, I will have already released the brake. I'm going to get you up in 4th gear. And then whenever you're ready, look down, make sure you got oil pressure, water temp, everything's good. When you nod your head, give me a thumbs up. I'm gonna push this green button, I'm gonna show it to you. That means it's logging. Just mat it, run it up as far as you feel comfortable, whatever that RPM is. Like I said, when you lift, I'm gonna pull you back down with this. All right. So when you get to the top, just put it neutral, clutch in, till I bring you all the way back down. Okay. That's really all there is to it. We're gonna do that 3 times, so we're gonna wait just a little bit in between the 3. Good deal. Jump on in.
And you and I are going to stand back over here.
Okay. Generally, when that number's higher than that number, the cam's a little bit on the small side. It's on the torquier side.
Okay.
But I think these things were, 225 at the flywheel from the factory, so it's better. And stick shift car usually loses maybe about 65, 70 horse through the drivetrain, so add 65 horse to that number there, and you know you've made some gains, you know, along the way. It's not bad by any means. She's pretty much done pulling by about $5 grand though, you know. So if you were racing, trying to shift or whatever, you'd still shift over here because the next gear pulls it back to here, so you'll stay in that band.
Sweet spot.
Yeah, she not much sense turning to 6 because it ain't doing anything out there. So I'd say maybe 5,500 on any pulls, 53, 55, something like that.
Okay.
Like I said, it puts it back in a sweet spot again. You could even argue that shifting a little earlier might put it back here in the sweet spot of the torque. These things, all the dynos correct the same way. At 5,200 and 52 RPM is where the torque and horsepower always cross.
Mm-hmm.
That's why somebody's been monkeying around with the graphs or whatever.
Oh, really?
Online.
I didn't know that. Okay.
Yeah, it's just a mathematical formula. All you're doing is looking at torque over time, and the 5252 is just part of the formula. So that's why all the dynos crisscross at that number.
Okay.
We'll give it just a second, cool the intake down or whatever, and again we'll pull it 3 times, and like I said, and we'll see if it gets better, worse, whatever.
Okay. I thought it would be a little more than that, but I guess it is what it is.
These dynos here are heartbreakers. You know, some of the dynos out there, you can fudge the numbers and everything else. This one, you don't. You got 2 big heavy weights that you're rotating, and it is what it is.
You do what you can with them, and that's it, right?
Yeah. But when you take the numbers from here and the car weight, and you go to an online calculator on what am I going to run in the 1/8 or the 1/4, this one directly correlates. A lot of the other ones don't.
Gotcha.
Where you go to Wallace Racing or whatever it is to look at their calculators and see what it's supposed to run.
There you go.
But like I said, it's a good bit better than from the factory.
Yeah.
The
factory, I think it was what, 220?
Yeah, 220, 225.
Crank.
It's got quite a bit better. Like I said, obviously if you change the camshaft around or whatever, these numbers are going to change a good bit. Let it breathe more up top. These numbers would continue to rise instead of just choke off and fall.
I figured it was pretty choked out. But
Yeah.
Same parts that come off the 302 when I swapped to the 351.
Usually if the fuel's off, the lines will be pretty bumpy. So it's a little bit, so it's not super happy, you know.
Okay.
You know, so you got a section here where it's real nice and smooth. The fueling's probably right there. It's probably got a little hiccup in a couple places. So this, you know, it could be fuel. I didn't see enormous black smoke or whatever, but I would say it's probably more the camshaft or heads or whatever than anything. If it makes less power, the timing could be a little high. So that's just something we'll look at on the next one. Generally, they'll get a little bit better. Like I said, if it goes the other way because of heat and timing are tied together, or heat. That's not
I know, I did. I've been told I set the time a little high. I set the base at 20. That's probably too high.
you know what full advance is?
Probably like, I don't know, 38 or 40, somewhere in there. I don't know.
That might be a little high for a full. That some heads will go quicker. Some of the old conventional small block. Not as quick as some of these LSs you want to run, 21, 22 degrees. So just depends on the cylinder head design and fuel you're using. There's some other factors, but those are the quick and easy ones.
No, there's nothing professional about anything besides me doing my research on my own.
Again, like I said, if we make this pull here and it slows down, maybe we ought to take a little time with it. I didn't hear any rattling or anything. 48 years listening to race cars, I might not hear everything.
You know a thing or two.
And the whole theory part of all this, looking at the graphs where it, where it starts to not be able to breathe anymore. If you just look at torque and you just put horsepower up when if you're just looking at the torque number, where it starts to fall off on the back side of the torque slope here, you can actually add timing and usually gain some power. So the number might not be wrong. There's no set number on all these things because there's so many variables. But since it's no longer, torque is a correlation of how well it's filling the cylinder. If you're on the back side of it, you're adding timing over there, you're just trying to create cylinder pressure again, trying to get back to that number. So
That's stuff you can do.
there's no way to say that that's wrong other than just trying it. See what happens.
That's something you can do with a computer program.
You can do it with a computer program, or we can just turn the distributor today. Let's go ahead and make this run and see what works.
Okay. Work for it.
That being said, it's probably not maxed out at the time.
Okay.
No matter what you go online, people told you. Because with the additional heat, it would have showed up. If it was having pre-ignition with the additional heat in the components, the pistons, some of the walls, some of the heads, and everything else, that number would have went down.
Okay.
Even that number, all the torque stuff, everything went up.
Everything went up. Well, what does that tell you? Just wasn't warmed up.
Either wasn't warmed up enough, or the timing's a little low actually, so being too high. But if you're planning on doing an aftermarket EFI system where you can move that stuff around or whatever, I wouldn't mess with it now. I would just go ahead and make the swap, and then you can get everything worked out then.
Gotcha.
But you could actually, like say this peak torque number or whatever, you could add timing on this side and this side, peak torque, and make more power everywhere. Make your horsepower graph a lot flatter.
Gotcha.
Because like I said, all you're trying to do is create cylinder pressure.
Okay.
Whether that's by spark, static compression, camshaft timing, intake, runners, all these different variables. That's all you're trying to do is try to get this as flat as you can get the damn thing. Flat
Gotcha.
and high.
Flat and high.
Okay. Very interesting. I appreciate it. You explaining it all to us. That's awesome.
Wheel, I like to keep running it, but a lot of people do go speed density and just run a map sensor. You can do it both ways.
That could be a pretty good bottleneck, I guess.
It could. Generally, they're large enough. They're not much of a restriction of heating. And for drivability and stuff, whatever, I actually like having them in.
Oh, okay.
I like to use them both, like the Chevrolet systems.
Okay.
But it doesn't have to. So my race car runs off the speed density. I think the drivability stuff gets better because with a mass airflow, you've got something upstream in the intake that's measuring steady state air. The map sensor's on the back side of the throttle blade, so it's measuring transitions. It's measuring kind of the total vacuum or how much air is going into the engine, but the numbers are a little more erratic. Because you're changing the butterfly from almost choked off to tip in and this, that, and the other. Where this is kind of some steady state stuff, but this doesn't see everything this does. Like say if you're going down the highway at 60 mile an hour and you dump the throttle and close it or whatever, this sees it immediately, right? This doesn't see it until the air that was rushing by backs up on the throttle blade and slows it down. So this one's got a little latency built into it, that audio metering and everything else that's doing video editing. This one's almost instantaneous, So they're both very useful, I think, for, even for wide open throttling. I like this one better, because you're not doing a transition,
Right.
So just, there it is. So a lot of people miss that whenever they get into the aftermarket EFI stuff. They're like, oh, the mass airflow stuff's junk, this, that, and the other. Well, Ford for a number of years used only a mass airflow and inferred the other one, through alpha and throttle position and RPM, and they inferred the map gauge. It wasn't even there, So you can do this stuff a number of different ways. None of them are necessarily wrong. They all have their applications.
Bigger heads, bigger cans.
Always, right?
Oh,
Not always, but most of the time.
And I do stuff a little different than most. Most people just throw in the biggest can that they can get. I kind of lean towards, and it's maybe not the wisest financial decision, but the best cylinder head that you can stick on the engine. And then you can choose a little milder cam, and everything works really well. You don't have to go so big. I mean, some of the stuff we used to run on small block Chevrolets, whatever, you wouldn't dare to run on an LS because the cylinder heads are so efficient. You don't need it. You'd have to turn the damn thing 10 grand. But kind of like even Japanese sport bikes and stuff, the cylinder heads are really, really good on those things. The camshafts aren't that wild. If you actually look at the load profiles, they're not that wild compared to a lot of stuff you see in American V8s and things like that. Because the cylinder head's so efficient, it doesn't need to be.
Okay. Would you be able to recommend what kind of cam it needs?
Yeah. I've got
I think it's a Pams XE275, blah, 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 something over here.
Yeah, that number is generally the advertised duration.
I called around when I put the 351 in, and I called the maker of the engine and asked for a cam spec, and he was like, giving me the ones for the 302. So that was something that I called, Southern Racing. I don't think they had any clue.
Sometimes the salesperson aren't the best
Yeah.
people to talk to.
Once I put it in and cranked it up,
against some
yeah,
of it.
sure. But I cranked it up the first time, I was like, wow, this really feels awful mild. I was hoping for something a little
Right.
more.
And I've had stuff in here that was again over cammed with really crappy cylinder heads. They don't make any power, So for the generation engine that is and everything else, those aren't bad. I've seen a lot of people with their popped up 5.3 LSs make a lot less.
Really?
But these big nasty cams in them and really shitty cylinder heads. Yeah, sometimes like I said, this machine will hurt your feelings, but it doesn't lie.
Well, I was realistically expecting 325 to 350 crank, so I guess it's pretty close to that.
Yeah, like I said, if you add in what you lose through the drivetrain, through the transmission, drive shaft, ring and pinion, the brakes on a passenger car are bigger than a race car, so there's some efficiency stuff that you lose. most of our race cars were in the 45 to 50 horsepower loss, you know, to the rear tires. There's that.
All right, jump back up on there again one more time.
A couple better, but I would about call that a repeat. Anything in the 2 to 3 horsepower range, or whatever, that's within the error range. That's about the same. 91 on the 93.
Okay. Cool. All right.
I'll let y'all talk while I unstrap.
That's that. Machine don't lie.
You know, automatic stuff or stuff with electronic throttle start having some issues there, but you don't have that. You're just cable operated, this, that, and the other. So you can, like I said, with it being a stick, you can get away with a lot more, and it doesn't just destroy the drivability. I would try that, and especially with an aftermarket AFI system, we can mask a lot of the problems you would normally have. Let's say fixed timing, by being able to put timing in and taking it back out where we don't need it. You know, so we can get aggressive on both ends and scoop a little bit out of the middle to get through the peak torque without rattling.
Okay. Well, I may play with it a little more and get the computer put on it and bring it back and let you make it right.
All right, sounds good.
I appreciate it.